Hi everyone, welcome back. Hope you had a lovely break. Forgot to mention that I won't be in for the next few Mondays because Melissa's come back to university. And I am minding Glenn, which is awesome for me. Not so awesome for you, but pretty cool. Anyway, I hope everyone had a good break and you're ready to get back into it. Today we are going to look at simple interest using recursion. And I know you're probably going, oh my god, recursion. That thing wrecks my head. But you actually all did really well on the exam or the test, the last test for the recursion. Maybe not so well in other aspects, but definitely good for that. So again, we'll just make it nice and easy, break it down, we'll just get into it. So today's lesson goal is, if it will work for me. So we're doing again financial maths, and we're doing the lesson goal to apply recursion to simple interest. So I'll just give you a few minutes there to take the goal down. And then from here, we're going to the APK. So the APK is to write the following as a first order recurrence relation. So you have a sequence here, 3, 7, 11, 15. If you remember, if you look back in your books, this is a simple one. So it just needs to be written in the form Tn plus 1 is equal to Tn plus D. And all you're really looking for, rest of it's a formula, all you're really looking for is what the difference. So I'll just give you a few moments here to work that out. Look back in your books if you need to talk to the person next to you. Okay, hopefully you have the answer Tn plus 1 equals Tn plus, the difference is obviously 4. So that's all you really need to do for that. And same here to now today, what we're going to work on to the sort of a given formula, and you're only really finding D every time. The rest of it looks messy, it's everything. I know it gets a bit confusing. Really, it's just a formula, and all you ever really have to do is find D. So here, so the simple input as recursion, the formula is Vn plus 1 equals Vn plus D, where D is equal to Vo times R over 100. I know now you're looking at this going, oh my god, my head's melted. I get it, right? First time I looked at this, my head was also a bit melted. But it doesn't, it's actually very easy. All you're really doing is finding D, and then you just slot D in, okay? So all, like this bit is always going to stay the same. All you really have to do is find D. What essentially is that saying is, whatever money you start with, you add D to it, which is D is the increase, and then you get the next number. So it's the next number up the line. This is what they actually stand for. So again, take this down. You can always pause the video here. In fact, I'm probably going to let you pause the video from now on because otherwise I'm going to be sitting here for ages. So VN is the value of the investment after n periods. So what that means is after 1 year, after 0 years, after 1 year, after 2 years, after 1 month, 2 months, whatever, however long it's getting simple interest. D is the amount of interest earned per period. So per period means, let's say if it's annually, so be how much interest would you earn after 1 year. And with simple interest, it's always going to be the same. Compound, it's slightly different. Remember, you add on to it. With simple, it's always the same amount of interest. It's the interest on the initial amount you invest or loan, etc. VO is the initial or starting amount. So VO is zero. If you think of it, the zero, the start amount to start with. So time is zero. And R is the rate of interest. So again, just take this down, pause the video here if you like. Take that down, take down what you need to take down, etc. And again, I know at this stage you may be a bit confused, but don't worry. It's actually quite easy. I'll do an example. So, example. I'll move my video out of the way. How do I move that? Here. So, 330 $325 is invested in a simple interest account for 5 years at 3% per annum. Set up a recurrent relation to find the value of the investment in after n years. Okay, so okay, so what all we ever really need to do is find D. Okay, so in this example, And we can slot the into the formula after. You could put the formula into the beginning with, remember that long formula you took down? You could put that in at the start. However, we can also just put it in at the end. All you ever really need to find is D. Okay? So D is VO times 100 all over, or times R all over 100. Starting amount, VO, 0. How much do I start with? Day 1, no time has elapsed. 0 time. It's $325, as you can see here, hopefully my armor. And the rate is 3, right? So I put this into a formula. Plug it in here. Do my calculation. It's equal to $9.75. So essentially what that is saying is every year I will earn $9.75 on my initial investment. So in the formula, we plug that into the formula. Remember, this was the formula we were given at the very beginning. These two values, when you're just writing a recurrence relation, they're always going to stay the same. Similarly, remember how we did it, the APK, Tn plus 1 equals Tn plus D. You're only ever asked to find D initially. Sometimes you might be asked to find out what it works out at, and that's the next thing we're going to come on to. But right now, all you're asked to do is find D. So we found D. That was pretty easy. And then all you do is you just put D into the formula. So Vn plus 1 equals Vn plus 975 dash, and then you always put the starting amount, right? VO equals 325. That was it. All you had to do was find D. This bit's always going to stay the same if you're asked to find a recurrent relation to the investment, right? These bit Vn plus 1 equals Vn. That's always going to stay the same for the initial formula. Obviously, when you start plugging in figures, which we're going to do in a second, those values are going to shift. However, for initial formula, this is always going to stay the same. So again, pause the video here, take that down, have a chat to the person next to you if you don't understand something, etc. And then use the recurrent relation to find the value of the investment at the end of each of the first 5 years. Okay, so table here, and I'll talk you through the table. The table's just done for you. So after, oh, sorry, I don't know what I've done there. Sorry, guys. Just so you can go over it again, right? Okay, so the table is actually, the answer's done for you, right? But I did it, right? So we started with, so what that's saying is this is the after 1 year. So you start with this much, Vn is this much, and then Vn plus 1 after the end. What that means is after the end of 1 year. So it's, you start with this much, that's how much you started, and then it's Vn plus 1. So all you do is you take the initial amount you started with at the beginning of the year, you add the interest for that year, because we calculated that already, and then you've got this new amount. Then for the second year, at the start of the second year, you have this much. You add again 975 to it, because that's always going to be the same for simple interest. Simple interest is always the same. And then you get this much at the end of 2 years. From the end of 2 years, so to start of 3 years, same difference. End of 2 years, start of 3 years, you know, it's literally New Year's Day, not much of a difference, whatever. Again, add your interest here. I don't know where my cursor's gone, it's after disappearing. Add your interest here. That's how much you've at the end of 3 years. Take this value, plug it in here, add 970 to it. That's how much you have at the end of 4 years. Take that value, add $9.75 to it, and this is how much you've at the end of 5 years. So that's your answer. But you can do it in a table like that. It's much easier if you do it in a table. So here, this is for you to do right now. So 2,500 is invested in a simple interest account for 7 years at 2.5% per annum. Set up a recurrent relation to find the value of the investment after n years. So all you're going to have to do here, it's going to look like this. I'll come back to it. It's going to look like this answer. This is going to be the exact same. This is going to be the exact same. This number is going to be different. And obviously that VO, how much did you start with? You started with 2,500. That's the only bit that's going to be different for your answer. So you need to just plug in the numbers here. Okay, so that's that step. And then the second step is you're going to do the exact same as you did here, but you're going to do it for 7 years. So you're going to have two more things. Your obviously starting value was 2,500. I don't know what your interest rate is going to be. And then you just add it on, get this value, put it in. So you're just doing the exact same thing I've been doing, okay? Again, if you have any questions, talk to the people next to you. Feel free to work in groups, pairs, etc., etc. And then when you're So that's really it for the day. So to complete, basically what you need to do right now is complete simple entrance as recurrence worksheet. That can be found under Google Drive under worksheets. So just complete that worksheet, and then when you're finished all that and you want to check out towards the end of class, you just go back to the goal review. Okay, so hopefully at the end you should be. I can use a simple interest as recurrence. So can you do it? Yes, and then I can answer worded problems. Yes. So if you can do those two things at the end of class, you're on track. I will see you. I don't know if I have you on Tuesday or not, but I'll see you the next class for definite. Okay, guys, have a great day. And looking forward to the rest of the term. Almost there. End of year 10. Take it easy. Bye bye.